Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video let us study how to solve some of the problems related to histogram. Already we know what is an histogram. So it is a graph over which we can plot the area representing a continuous frequency distribution. So let us consider the first problem. The first problem here is draw histogram for the following data. So what is the given data? We have been presented with class interval. Along with the class interval, frequency is also given. So the class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. If you observe the class interval, all the class intervals are in equal width. What is the width? The width C here is 10, that is 0 to 10 is width is 10, 10 to 20 width is 10. Okay, how to find the width? That is C, higher upper limit minus lower limit. What is the upper limit? For example, for the class interval 10 to 20, the upper limit is 20, lower limit is 10. So 20 minus 10 is 10. So that is the width of the class. Since the width is equal, and here we have been presented with the frequencies corresponding to each class. For each class there is a frequency given. We can easily plot the histogram. So this is a histogram corresponding to the first problem. First we need to consider the scale, x-axis and y-axis. So what does x-axis indicates in a histogram? Always x-axis will consider the class interval, that too continuous class intervals. Please notice here what is the class interval here. Here it is a continuous one, 0 to 10. From here 0, 10, followed by next 10 to 20, 20 to 30, 30 to 40, 40 to 50. Isn't it? So this is the class interval. So always in the x-axis we will be considering the class interval. Okay. Next, in the y-axis we will be considering frequencies. So what is the scale for frequency? That is y-axis. Y-axis 1 centimeter is equal to 2 units. 1 centimeter will say what? It will say that 1 centimeter is equivalent to 2 units. Fine. Okay, now we will need to erect the rectangular bars. Already you can see there are rectangular bars erected corresponding to each class interval. Okay, so what is the length of the rectangular bar? So the length of each rectangular bar is directly proportional to the frequency. For example, for the first class interval, that is 0 to 10, the frequency is 13. So the height corresponding to 13 will be the first height of the first bar. Next, what about the width? So width of the rectangular bar will be proportional to the class width. So what is the class width? 0 to 10, 10. Okay, you can observe here all the rectangular bar width is same, because all the class intervals width are same. That's the reason. Okay, so and also the noticeable feature here is each rectangular bars are erected adjacent to each other without giving any space. Okay, so this is the histogram plotted for the first problem. Now let us consider the second problem. Draw histogram for the following data and hence locate the mode. So what we need to do here in this particular problem, first of all we need to draw the histogram, and via histogram we need to plot mode, that is Z value. What is mode? Highest frequency. So here we have been presented with a table. Wages is represented in terms of rupees. Okay, that is in terms of thousands of rupees, followed by number of workers in the second row heading. Next, wages 2000 to 4000, next 5000 to 7000, 8000 to 10,000, like that they have given the values. And also number of workers they are getting the salary. 2 workers are drawing the salary 2000 to 4000 rupees. Similarly, there are 25 workers, they are drawing the salary 11,000, between 11,000 to 13,000. Okay, similarly there are 20 workers, they are drawing salary between 20,000 to 22,000. But here the noticeable thing here is the class interval 2 to 4, then 5 to 7, 8 to 10, like this. Please, if you observe here, observe the class limits. both lower limit and upper limit are included in the same class interval. Nothing but these class intervals are inclusive class intervals, isn't it? So both lower limit and upper limit, they are included in the same class interval. So if you plot histogram for this given data, then you won't get a proper graph. The reason is 2 to 4. Okay, let us say that there are two workers getting 2000 to 4000 salary. Let us say I'll be erecting one bar for frequency 2 for the class limit 2 to 4. Next, there will be a gap because from 4 to 5 there is no frequency mentioned here. So there will be a gap that is observable in the histogram. But what does histogram says? We need to erect rectangular bars adjacent to each other without giving space. So this is not a correct way. So what we need to do, we need to make certain changes. What changes? We need to convert this inclusive class interval to exclusive class interval. How to go about that? Very simple. You need to add the correction factor here. That's all. First of all, you need to identify the correction factor. From the lower limit, you need to subtract the correction factor, and to the upper limit, you need to add correction factor. Okay. So what is correction factor? So correction factor is nothing but lower limit of the second class minus upper limit of the first class divided by 2. Very simple. So here, which is the first class? So so the first class is in the previous question. The first class is 2 to 4, and second class is 5 to 7. Okay. So what is the lower limit of the second class? That is 5 to 7. The lower limit is 5. What is the upper limit of the first class? The upper limit is 4. Okay. In the first class is 2 to 4. So the upper limit is 4. So we will be subtracting lower limit of the second class, that is 5, minus the upper limit of the first class, that is 4. So 5 minus 4 divided by 2, that is 1 by 2, will give us the value 0.5. So usually always we will be getting 0.5 as the correction factor usually. So we need to convert now the inclusive class interval to an exclusive class interval. So how are we going to do that? As I said earlier, from the lower limit we need to subtract, and for the upper limit we need to add the correction factor. So in the question, in the given question, the first class interval, that is 2 to 4, what is the lower limit? 2. So 2 minus 0.5 will give 1.5, and for the upper limit 4, if you add 0.5, it will give us 4.5. Same thing will be carried forward for all the class intervals. Okay, for the second class, in the given question, the second class is 5 to 7. From the lower limit, we will be subtracting 0.5, so we will be getting 4.5. For the upper limit, that is 7, we will be adding 0.5, we will be getting 7.5. So same changes need to be maintained for all the class intervals so that we get a exclusive class interval. There will be no change in frequencies. Okay. So once we get a exclusive class interval, now we are ready to plot the histogram. Let us do that. So this is the histogram. Please notice here. So in the x-axis, we will be indicating the class intervals. In the y-axis, we will be indicating the frequencies. Before plotting the histogram, we need to consider the scale. So x-axis and y-axis. What is x-axis talking about? It says that 1 centimeter is equivalent to 3000. Okay, what? Rupees, 3000 rupees. So in x-axis says that 1 centimeter is measuring 3000 rupees, and y-axis it says that 1 centimeter is equal to 5 workers. You can say 5 workers, 10 workers, 15 workers, 20 workers, like that. Okay. So now let us plot the histogram. So please notice here, from 0 to 1.5 there are no rectangular bars erected. Why? What is the reason? Because it's given in the question itself. We have started the class interval from 2 to 4, which was inclusive, but later we converted it into exclusive. So we got first class interval as minus 1.5 to 4.5 as a first class interval. Nothing but here we will not be erecting any columns or any rectangular bars. We need to leave this space. So from here we will be erecting rectangular bars. So for the first class interval, that is 1.5 to 4.5, the number of workers are 2. So we will be raising the rectangular bar. Next, for 4.5 to 7.5, next is the number of workers is 6. Similarly, for 7.5 to 10.5, the number of workers is 8. So it goes on. After erecting all the bars, we have done with half of the question. We have solved only half of the problem. Now, rest is we need to find the mode using the histogram. What is the procedure to find mode? Very simple. First of all, we need to locate the tallest rectangular bar among all the rectangular bars. So the class interval 13.5 to 16.5 is having the tallest rectangular bar. Okay, so from this rectangular bar, the upper vertices, we need to draw a line from upper vertices to the opposite rectangular bar upper vertices. Okay, like this. From here we'll be joining a straight line to this vertex, to the next rectangular adjacent rectangular bar. So from here again we are drawing a line which will be connecting to the upper vertex of the adjacent rectangular bar. So after drawing these diagonal lines, we will be getting an intersection point. So from the intersection point, we will be drawing a line perpendicular to the x-axis. So the line which meets the x-axis, where it meets the x-axis, that particular point, that particular juncture is referred as the value for mode. Nothing but it is the highest frequency. Okay, so this is how you are going to get mode, that is highest frequency, using histogram. Okay, so this is done. This is the way we need to find solution for histogram mode using histogram. Now let us attempt the third problem. Draw histogram for the following data and hence locate a value of mode. So we need to locate what is the value of mode, we need to say. So if precisely if you want to say what is the mode, then better always it is good to plot the histogram using a graph sheets. Only in graph sheet we can precisely say what is the value of z. Okay, fine. Let us go through the table. So marks and number of students have been given. Marks is in terms of class interval 0 to 5, 5 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 70 and 70 to 80. If you observe these class intervals, are they of equal width? Here please notice here the first class interval is of width 5. Here also 5, but here 10, here 10, 10, 10, here 20, again 10 here. So here the class intervals are of not equal width, they are of unequal width. So if the class intervals are of unequal width, then how to construct histogram, how to plot the histogram? We cannot go by this frequency. Okay, we cannot construct histogram by frequency whenever we are having class intervals of unequal width. Then we need to consider what? Frequency density. What is frequency density? Very simple. Frequency of the class divided by width of the class. Very simple. For example, what is the frequency density of the class 0 to 5? Frequency is 2. 2 divided by width is 5. 2 divided by 5 will give us the value, that is 4.5 will be the frequency density. So we need to construct a new table which will be having another column called as frequency density. Let us do that. Please notice here, I have constructed a new table, marks, number of students, which was given earlier. But now I have to consider a new column for my table, that is width. What is width? Class width of the class interval. So 5 minus 0 is 5, 10 minus 5 is 5, 20 minus 10 is 10. This will give me the width of each class interval. As you can notice, the width is not same for all the class interval. There are different widths, 5, 5, 10, 10, here 20. There is a change. Since there is a change in the width, I need to notice what is the frequency density. What is frequency density? Frequency of the class divided by width of the class. 2 by 5, 6 by 5, 8 by 10, 25 by 10, 40 by 10, 30 by 10, 20 by 10, 20 by 20, sorry, 8 by 10. Like this, we will be getting frequency density. So now we can plot histogram. So now while plotting the histogram, what need to be considered? We need to consider only the class intervals, that is marks and frequency density. Rest these two columns need to be neglected. They are of no use now. So we need to consider only the class interval and frequency density. So first we need to consider the scale. X-axis will indicate what? 1 centimeter is equal to 10 units. So x-axis it says that 1 centimeter is equal to 10 units, and y-axis says that 1 centimeter is equal to 1 units. Fine. Okay. First of all, we will be erecting the rectangular bars. So for the class interval 0 to 5, please notice here there will be change in width. For the class interval 0 to 5, what is the frequency density? 0.4. 0.4. Next, for the class interval 5 to 10, what is the frequency density? 1.2. So next, for the class interval 10 to 20, please observe here the complete width of the rectangular bar is little bit bigger, wider, isn't it? Compared to the first two rectangular bars, here you can notice here the rectangular bar width is little bit high compared to the first two rectangular, because the width is 10 here. So for the class interval 10 to 20, the frequency density is 0.8, 0.8 somewhere here, 0.8. Next class interval 20 to 30, the frequency density is 2.5. Similarly for 30 to 40, 40 to 50, but observable thing is 50 to 70. 50 to 70, the width is 20. You can observe here this rectangular bar is even wider compared to the earlier one, because the width is 20. So for 50 to 70, the class interval, the frequency density is 1. Similarly followed by the last one is 70 to 80, the frequency density is 0.8. So after erecting all these rectangular bars, now we need to find the mode. How to find the mode? We need to join the edges of the tallest rectangular bar with the adjacent edges by diagonal line, okay, using vertices. Okay, so first we will be joining these two lines. We will be getting an intersection point. From the intersection point, using scale, we will be drawing a straight line, perpendicular line, which will be meeting the x-axis. So the point where it meets the x-axis, that is the mode. So here in this case, if you draw the diagram using graph sheet, then precisely you can say that mode here, z value is 36. Okay, so we are in the class interval 30 to 40, so z is coming at 36. So we can say that, so by plotting the histogram, we can say what is the value for mode, that is z value here, it is 36. Thank you.